College Algebra. We're going to wrap up lesson 5-6 today. Before we get started on the application side of the lesson, which is the linear programming part, I'm going to show you how to handle a question like number 78. Number 78 is on page 570, and it says the graph shows a region of feasible solutions. Find the maximum and minimum values of each function, each objective function. When we get ready to do the word problems that are associated with these, you're going to see how we come up with these regions. And basically, once you do the word problem, you're going to have a polygon that will be shaded. The polygon will have vertices, and those are the ordered pairs at the corners. What you're going to be doing is you're going to be plugging in those points into the objective function, and you're going to come up with a maximum or minimum value for the function. All of this is going to show up again in the word problems, and then I think you'll understand more of what we're after. But I just wanted to show you first how to handle the polygon, the points, and the objective function. So what I would do is I would just set up a table, and on one side I would put in the objective function, and on the other side I would just put value. So for the ordered pair 1, 2, so I'm going to start right here. I'm going to plug in 1 for x and 2 for y. And 6 times 1 plus 2 is 8. Then I'm going to do the 1 and the 5, and that's 11. Then I'll plug in 6 for x and 8 for y. And that will be, let's see, 36 and 8, 44. And then finally I'll plug in the 9 and the 1. And that's 55. All right, we call 8 the minimum value. And 55 the maximum value. And if you go back and read the directions, they want you to find the minimum and maximum values for each objective function. So that's all you have to do there. Now, why do you need to know this? You need to know this for word problems that are called linear programming problems. So page 564 in your book has the problem that we're going to start off with. And it says the following. Earthquake victims in China need medical supplies and bottled water. Each medical kit measures a cubic foot and weighs 10 pounds. Each container of water is also a cubic foot and weighs 20 pounds. The plane can carry only 80,000 pounds with a total volume of 6,000 cubic feet. Each medical kit will aid 6 people, and each container of water will serve 10 people. How many of each should be sent in order to maximize the number of victims aided? What is the maximum number of victims? What we're going to do is set up a system of linear inequalities. We're going to graph and shade, and then the shading will produce a region that has ordered pairs for the vertices, and then we'll test that back into our objective function to answer the questions. So first of all, we need to decide our variables. So we're going to go with X, medical supplies, medical kits. We're going to let Y be the number of containers of water. All right. Now what we have, we know we're sending positive amounts, so both of those are going to be greater than 0. You can write that down if you want. Okay. You might decide not to send any of either, so that's why they're equal to 0. You need an equation or an inequality now for the weight and then you need another inequality for the volume. Okay, it says the plane can have 80,000 pounds on it, and a medical kit weighs 10 pounds, so 10x, and a water container weighs 20 pounds, so 20y, and we needed that to stay under 80,000 pounds, okay, or equal to. We can't go over that. And then for volume, we know that the medical kit takes up 1 cubic foot of space, and the water takes up 1 cubic foot of space, and that has to stay underneath a volume of 6,000 cubic feet. What we're going to do is we're going to graph these by looking at intercepts. So I'm going to start with this one. So if this were an equation, I would have an x-intercept and a y-intercept. So to find my x-intercept, the y becomes 0. If you plug in 0 for y, you're going to end up with 80,000 divided by 10. And if you plug 0 in for x, you'll get the y-intercept, and 80,000 divided by 20 would be 4,000. All right, I'm going to do the same thing for this one. For the other equation, my intercepts are going to be 6,000, 0, and 0, 6,000. What I'm going to do next is graph these. Try to make my lines as straight as I can for you. Okay, now we need to graph these ordered pairs that I have highlighted. And so what you're going to want to do is come up with a reasonable scale. So I'm going to say this is maybe 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be 1,000, and that's my scale. I'm going to do the same thing going vertically. Remember that your x, that's the number of medical kits, and your y, that's water. Okay, so now we're going to graph our ordered pairs. 8,000, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 0, 4,000. Six thousand, 0, and 0, 6,000. Now, if you're using a ruler, which I highly recommend, you're going to find that your points intersect. And your points are intersecting here. Well, if I would have drawn these straight, your points should be intersecting at 4,000, 2,000. So that point of intersection should be here. My lines aren't very straight. If you're wondering where that point of intersection is, you can always do substitution or elimination to find that out. So if I multiply by a -10 to do elimination, I can see there that my y is 2,000. So my x must be 4,000. Okay, so this is the ordered pair 4,000, 2,000. Now again, that's really hard to see on my graph because my lines aren't straight, but if you're using graph paper, you should have an easier time reading that ordered pair. We're less than on both, so the region that we're looking at is going to be this one here. Okay. What we're going to do next is we're going to take every one of these points, these vertices that I'm making nice and big. Each of these vertices needs to go into our table, and we have to work with our objective function. Your objective function is going to be the fact that each medical kit helps 6 people, so that's 6x. And each water container serves 10 people, so that's 10y. And then you're going to plug in your ordered pairs into each one. I will pause my video and we'll come back to that here in just a little bit.